In this lesson, we're going to look at dealing with parallel lines. We're going to do two examples. They are pretty much the same, I would say. The one just has more working, so the mark allocation would be higher. And I know, grade 10s, that a lot of students think when the mark allocation is higher, it means that the question is more difficult. Not necessarily. It just means that there would be more steps that we need to show. All right, so there's information that you need to know, there's knowledge that you need to have about parallel lines. If you feel a little bit lost in this section when we look at parallel lines and in the next lesson on perpendicular lines, it just means that maybe you missed a little bit of information with your grade 9 straight line graph, or maybe your teacher called it the linear function. If that is you and if you feel a little bit lost in the next two videos, just refer back to grade 9 linear function or the straight line graph. It just means that you've got a gap in your knowledge there, and we don't want you to lose out on marks for your analytical geometry because you missed something in grade 9. Okay, so let's get going with this question. So if we read there, it says, find the equation of the line, and you need to know what the equation of a line will look like. Well, our standard form is y is equal to mx plus c. All right, if the two lines are parallel, they give us that these two lines are parallel to one another. So we have got the equation of this line, so that's clearly not the one that we need to find. So we need to find the equation of this purple line. So let's just quickly investigate and see what's going on. What do we know about the purple line? Well, we know that there's one coordinate there. They gave us 1 point on that straight line. That's not enough information. When you've got 1 point on a straight line, that is not enough information to get the equation of that line. So we're going to have to use some information from the pink line. Well, we have got that the equation of the pink line is equal to y is equal to x plus 6. So in this case, our c value being 6 and our m value, what is our m value there? It's just 1. The coefficient of x there is 1. And our m is just our gradient. That m value just represents the gradient or the slope or the steepness of the line, and that c value, that constant value, represents the y-intercept. Where does the line cut the y-axis? Okay, let me not get into too much linear function stuff. All right, so we need to find the equation of the purple line. We only have 1 point on it. It's not enough information. So we need to use some of the pink graph's information. Well, the knowledge that you need to have about lines that are parallel, they share the same gradient. The gradient will be exactly the same. So if the gradient of the pink line is equal to 1, then it means that the gradient of our purple line will also be equal to 1. So therefore, the gradient for the purple line that we are trying to find is equal to 1. So we can go substitute that in so long. So into the equation of our purple line, our m is 1, so I'm just going to plug it in like that for now. I'll leave it out in the next step. We don't have to show that. Plus c. We don't know what that is. But now that we've got a little bit more information, that point that they gave us on the line should be enough information for us now to find the value of that c value. So I'm going to plug in the coordinate on the line that they gave us. And in the place of y, I plug in a 0. In the place of x, I just plug in a -2 there, and then plus c. So if I take that one over, I'm going to land up that c is equal to 2. So therefore, the equation of the purple line is y is equal to gradient of 1, x plus 2. And there is the equation of the purple line. Using that idea that parallel lines share the same gradient. Find the equation of g of x. So g of x is that darker blue one. G of x, we need to find the equation of that line if the two lines are parallel. So we got given that these two lines are parallel, and then there is knowledge that we need to have. We need to know that the gradient of the one line is equal to the gradient of the other line because they are parallel. We know that. All right, so if we need to find the equation of g of x, we know that it will be in the form y is equal to mx plus c, our standard form of our straight line graph. We've got two missing pieces of information. We need to find the gradient and we need to find our c value, our y-intercept. Okay, well, there's not just one way that we can do this. So however you understand this and where your mind goes, that's perfectly fine. If I'm looking at this now, I can see that they gave me that point over there of 0 and 5, which is actually the y-intercept of that graph. We know that 1 point is not enough to be able to find the equation of a line. But what I'm going to go do now is I'm actually going to go plug in my y-intercept. My c will be 5 because your c is your y-intercept. So y is equal to, I don't have the gradient, but I know my y-intercept is 5. So I am missing that information. We need to bring in the other line on this because they are parallel. If I can get the gradient of my light blue line, then I can use that for the gradient of my dark blue line because they are parallel. Okay, well, we don't have the gradient of the light blue line yet, but we can go find it because we've got 2 points on that line. You need 2 points on a line to be able to calculate the gradient. How do we calculate the gradient? To find the gradient, in this case of f of x, it is your change in y. So I'm going to say -2 minus 4, subtracting my two y values, and then 0 and take away a number that is already negative. I'm finding my gradient for the light blue line. That will give me that plus 3. And then my gradient for the light blue line will be equal to -2. And that makes sense if I look at the direction of the line. So the gradient of my light blue line is -2. So therefore, the gradient of g of x that we're supposed to find will also be equal to -2 because they told us that the lines are parallel. So therefore, what is the equation of g of x? It will be equal to -2x plus 5. And there we go. We can also just write it in that notation. G of x is equal to -2x plus 5. And there we go. We found the equation of a straight line by using the idea that lines are parallel.